In this video, I will explain how to calculate distance and displacement on a velocity versus time graph. So let's jump right into an example. This says, find the distance traveled and the displacement of the following particle between 0 and 15 seconds. So we're given this graph here where the y-axis shows us the velocity of this particle, and that's given in meters per second. And the x-axis shows the time, and that's given in terms of seconds. So first let's find the displacement. So the way we're going to find the displacement is we're going to find the area between this line right here that we're given and the x-axis. And any area below the x-axis, that's going to be negative displacement. And any area that we calculate above the x-axis, that's going to be positive displacement. And I'll explain why in a minute. So first things first, let's try to just break up this line that we're given into segments. So it looks like there are 1, 2, 3 distinct segments. So here's what we're going to do. For this first line segment, let's color that blue right here. We're going to find the area between this line segment and the x-axis right here. So we're going to find this area. Then for the next line segment, so this piece right here, we're also going to find the area between this line segment and the x-axis right here. So let's go ahead and color that red. And we'll notice this is going to be a triangle. And lastly, we're going to find the area between this line segment, so this final piece of the line right here, and the x-axis right here. So that's also going to be a triangle that we're going to find the area of. So first let's focus on this rectangle. The area of this rectangle is simply going to be the base times the height. So the base is going to be the distance from 0 to 5. So this is just a 5 right here. And the height, let's call this the height, that's the difference between 0 and -4, which is -4. So if we do -4 times 5, that's -20. So let's write -20, and the units that we'll use is meters. So let's break down what we just did here. We said that from 0 to 5 seconds, this particle traveled -20 meters. That was the displacement of this particle. And why is that? Well, remember the y-axis, that's telling us the velocity. So what this is saying is that we travel at -4 meters per second, and we do that from 0 to 5 seconds. So for 5 full seconds, we're traveling at -4 meters per second. Now, when we're talking about velocity, negative just means we're moving backwards. So really what this is saying is that we're moving at -4 meters per second, and we're doing that for 5 seconds. So -4 times 5, that's a total of -20 meters, or in other words, we moved backwards 20 meters. So that's how to interpret that value. Okay, now let's focus on the area of this triangle right here. So the area of any triangle is just 1/2 times the base times the height. So the height of this triangle right here, that's the difference between 0 and -4. That's -4. So let's write that right here. And the base, that's this distance right here. So we can see that's from 5 to 10. So that's 5. So to find the area of a triangle, we just do 1/2 times the base times the height. So 1/2 times -4, that's -2, times 5 is -10. So the area of this red triangle, we'll say that's -10 meters. And lastly, we need to find the area of this purple triangle right here. So again, we're going to use the formula 1/2 times base times height. So the base, let's call this side the base. That's the difference between 10 and 15, so that's 5. So we'll say 1/2 times 5 times the height of this triangle. That's going to be this side of the triangle right here, which looks like it's about from 0 to up here is 8. So this side right here is 8, or we'll call this the height of the triangle. So let's write that right here. So the area of this triangle is 1/2 times 5 times 8. So 5 times 8 is 40, and 1/2 of that is 20. So the area of this purple triangle is positive 20 meters. And again, whenever we're calculating area below the x-axis, these are going to be negative values. And whenever we're calculating area above the x-axis, that's going to be a positive value. So that's why it's positive 20 meters. So the total displacement, to find that, all we have to do is add these values. So -20 meters plus -10 meters plus positive 20 meters, that turns out to be -10 meters. So let's write that down. So we would say the displacement of this particle is -10 meters. Now to find the distance traveled, all we have to do is add the positive versions of each of these numbers. And the reason is because distance is always a positive value. So even though the displacement, for example, of the first 5 seconds is -20 meters, we're still traveling 20 meters. So that's still a positive distance of 20 meters. And for this second 5 seconds right here, we travel -10 meters, so we're going backwards 10 meters. That's still positive 10 meters being traveled. And then lastly, for the last 5 seconds, we have a positive 20 meters. So the distance is simply going to be positive 20 plus positive 10 plus positive 20, and that turns out to be 50 meters. So let's write that down. So we would say that the displacement is negative 10 meters and the distance traveled is 50 meters. So that's how you can find distance traveled and displacement when you're given a velocity versus time graph.